Hi children, welcome to my YouTube channel. This is the second video of the video series, The Moments. In last video we have discussed how to find the moment due to single force acting on an object. Today we are going to extend the theory to find the resultant moment due to multiple forces acting on an object. To obtain the resultant moment due to multiple forces, we have to follow up certain steps. From this question, let's try to understand how to find the resultant moment using those steps. Right. Initially in this question, they mentioned the diagram shows a set of forces acting on a light rod. Calculate the resultant moment about point P. Right. Step 1. What you need to do is calculate the moments and mark the directions from given point P. Right. If you start with the first force, 3 Newton. The force is 3 Newton. From point P to 3 Newton, the perpendicular length is 1 meters. Therefore, moment is 1 into 3 Newtons. So now see whether if you try to find the direction, it perform an anti-clockwise moment. If you don't know how to do it, refer with my first video. And I will mention you the link in the description box, as well as it will pop up as a suggestion video at the top of this screen. Right. Then if you move up to the force of 4 newtons, the perpendicular distance is 1 meter and the force is 4 newton. Therefore the moment is 1 into 4. That one also perform an anti-clockwise moment. If you come up with the force of 5 newton, the length from P to 5 is 1 plus 2, that is 3 meters. The force is 5, that is 3 into 5 newtons. So with that you will obtain the answers 3, 4 and 50. Right. Then we'll come up to the next step. The second step would be, now it's up to you the way you can consider these facts. Consider clockwise as positive and anticlockwise as negative, or anticlockwise as positive and clockwise as negative. It's totally up to you the way you select it. Not a problem. Any you can use any way you like to apply for it. Right. Then my preference is I will consider the clockwise as positive and anticlockwise as negative. Now the first one is an anticlockwise. No? Therefore I'll put a minus in front of that figure. Second one also anticlockwise. Then you have to put minus. Then the last one is clockwise. Therefore I'll put plus for that. Then I will obtain the answers minus 3, minus 4 and plus 15. If you simplify this figure, I can gain the answer 8 Newton meters, that is a plus value. Then at the beginning, I have considered plus value as clockwise moment. Therefore, the final moment for this question would be 8 Newton meters clockwise. Hope you have understood how to get this answer. Let's start this question. Here the diagram is given. We need to find the resultant moment around point P. First I will start with step 1. The force 3 Newton. The moment is 1 meters into 3 newtons. That perform a clockwise moment. Then the next force is 2 newtons. The other moment is 1 into 2. That is perform an anti-clockwise moment. Again, if you work out with force of 4 newtons, the length is 3 meters and force is 4 newtons, that is a clockwise moment. Then step 2, the first one is a clockwise moment, therefore I will put a plus in front of that. Next one is an anti-clockwise moment, I will put a minus in front of that. Third one is a clockwise moment, I will put plus into that. It's totally up to you. Since I have considered the clockwise as positive and anti-clockwise as negative, there you get this answer as shown. But in a case if you get the opposite of it, That means if you consider clockwise as negative and anti-clockwise as positive, you will obtain the first answer negative, next answer positive, and next answer negative. You just work out and see. With that, you will obtain the answers plus 3 Newton meters, minus 2 Newton meters, and plus 12 Newton meters. You will obtain the answer 13 Newton meters is a positive value. Therefore, you can write your final answer as 13 Newton meters clockwise. Then if you consider the opposite way, that means if you consider clockwise as negative and anti-clockwise as positive, with that you will obtain the answer minus 3 plus 2 and minus 12. Then you will get the answer minus 13 Newton meters. There, for that case, a minus 13 minus value you have considered for clockwise. Therefore, your answer would be 13 Newton meters clockwise. So, whatever the way you refer to do it, you will get the answer same way. Nothing to worry. If you are confusing with this, please drag this video a little bit back and listen to me, listen to my explanation clearly. Let's work out this question. Here the diagram, we need to find the moment around point P. I will follow up the step 1. The moment due to force 4 newtons, that is 2 into 4, that is anti-clockwise. Then moment due to force 3 newton, 1 into 3, that is clockwise. The last one is the force due to 7 newtons, that is length is 2 meters and force is 7, that is 2 into 7. That one also perform an anti-clockwise. Then I will consider the clockwise as positive and anti-clockwise as negative. With that, the first fact it would be negative, next fact would be positive, and last one should be negative again, because it's anti-clockwise negative, clockwise positive, and anti-clockwise negative. With that, you will obtain the answer minus 8 Newton meters, plus 3 Newton meters, and minus 14 Newton meters. Then I have obtained a negative value, negative 19 Newton meters. What I have considered as negative? I have considered negative as anti-clockwise. Therefore, the final moment is 19 Newton meters anti-clockwise. From where I have selected the direction? From that minus mark. There with that you can say the final moment would be 19 Newton meters anti-clockwise. Hope you have understood this concept. The next theory today is to learn is equilibrium of an object. We have already learned this theory in our IGCSE syllabus, but we will review this section because that is very important to work out the questions in this topic. Right. If an object remains in equilibrium, definitely it must satisfy two different conditions. If the object satisfies both of these conditions, only you can say that object remain in equilibrium. In the other sense, if we know an object remain in equilibrium, definitely it should satisfy these two conditions as well. That is the concept you have to get it right. The first condition is the resultant force in any direction must be 0. Then you cannot to understand whether this condition is satisfied by a certain object, we cannot mark all the direction and we cannot find the resultant force on that. To rectify this situation, we use one technique. What is that technique is, we will consider two directions perpendicular to each other. Then we will get the resultant force along those two directions. If the both values are 0, we can simply say the resultant force in any direction would be 0 in the particular object. The second condition is the resultant moment must be 0. That means if you calculate the clockwise moments and if you calculate the anti-clockwise moment, those must be similar to each other. Or if you get clockwise moment minus anti-clockwise moment, that should be equals to 0. That is the way you can understand that the resultant moment must be 0. We will learn these concepts much clearly in our future slides. Let's try to check the condition 1 for this object. There are few forces acting on the same object. Three horizontal forces, 10 newtons, 20 newtons and 30 newtons, and two vertical forces, 10 newtons and 15 newtons act on this object. Right. If you consider the horizontal equilibrium, whether it's in equilibrium in horizontal or not. So if you work out with that, I will put an arrow horizontally, then I will consider the forces onto that direction as positive and opposite forces are negative values, right? Therefore, you can put plus 10, plus 20 and minus 30. Since the 30 is into the other direction, then I consider. The final answer is 0. Therefore, you can say in horizontally, forces are in equilibrium. Then we will consider the vertically whether it's in equilibrium or not, right? Then we can work out. I have considered the arrow upwards, therefore I will consider the upwards forces as positive values and downwards forces as negative values. Then if you get these vertical forces, that would be 15 newtons minus 10 newtons, that is 5 newtons. Therefore, we cannot say the resultant force in any direction is not 0. The reason is that horizontally that is equal to 0, but vertically it's not 0. Therewith that you can say it does not satisfy the first condition for this object. Let's try to check the condition 1 for this object as well. If you consider the horizontal equilibrium, whether it's in equilibrium or not, if you work out, that is 100 newtons plus 100 newtons plus 200 newtons minus 300 newtons, that is it turn up into 0. So horizontally it's in equilibrium. If you consider the vertically, it should be plus 100 and minus 100, that one also equals to 0. Therefore, we can say resultant force in any direction is 0 and it satisfies the condition 1. Now, you have to understand the satisfaction of condition 1 out of these two examples. Let's try to move up this question. The diagram shows a uniform rod AB of length 3 meters and weight 20 newtons resting horizontally on supports A and C, where AC, the length of AC is 2 meters. Calculate the magnitude of the reaction at each of the supports. Now let's try to understand this question. They mention object remain stationary, or they mention it as resting horizontally. That means object is on equilibrium. That's the first concept you have to understand from this question. The next theory is they mention that object is, or this rod is uniform. If any rod is uniform, we have to understand that the weight exactly acts on the midpoint of the rod. In another term, we call the center of gravity would be the exactly mid of this rod. We know that the length of the rod is how much? It's 3 meters. Therefore, the center of gravity or the weight acts at a point 1.5 meters from A or from B. That's the second concept you have to understand this question. The next concept is if you keep an object on pegs as shown in the diagram, there would be reactions upwards from these pegs. Therefore, we have to mark the reactions acting from A and C upwards on this object. Those are the facts you have to consider when you are working out with this question. To work out this question, initially I will mark the center of gravity from 1.5 meters from A. If you mark it from B, even the same length 1.5, since the center of gravity is at the midpoint, because the rod is uniform, and you can mark two reactions R1 and R2. Remember that these two forces are not similar. Therefore, you have to mark it as R1 and R2. There are conditions comes with the R1 and R2 are similar. We will discuss those conditions in later videos. Then I'll mark as R1 and R2. Then how to find the values of this R1 and R2? We know that object remain in equilibrium. Therefore, I can write Upwards forces equals to downwards forces. R1 plus R2 is equals to 20 newtons. I will consider that one as my first equation or equation A. Then the second condition, the resultant moment is 0. Therefore, you can work out clockwise moments equals to anti-clockwise moments. So I will consider the moments around point A. That is easier for me to do it. Then if you work out with that, you will understand that that is 1 point clockwise moments 1.5 into 20 newtons equals to anti-clockwise moments. R1 into, I am consider the moments around A, no? So therefore the distance is 0. So therefore R1 into 0 plus R2 into 2. Therefore you can work out the value for R2 as 15 newtons. Then we know that R2 is 15. From first equation or equation A, we can find the value for R1 as 5 newtons. Then I have already found the figures for R1 and R2. In this question, a uniform rod AB of length 5 meters and weight 30 newtons kept on two pegs C and D, which is 3 meters apart from each other. That means A to C is 1 meters, D to B is 1 meters. Therefore, since the total length is 5 meters, you can say that CD should be 3 meters. So the diagram is as shown over here. Now we know that the rod is uniform. Therefore, I can mark the weight W1 equals to 30 Newton from 2.5 meters, half of 5 meters from A, or if you want you can mark it from B1, doesn't matter, you get the same length. Then I can mark the two reactions R1 and R2 over two pegs on C and D, right? Then we know that object remain in equilibrium. Therefore, I can consider the first condition, upwards forces equals to downwards forces. With that you can say R1 plus R2 equals to 30. I'll consider that equation as my first equation. Then I'll consider the moments around A. If I consider the moments around A, I can say clockwise moments equals to anti-clockwise moments. What are the clockwise moments? 2.5 meters into 30 Newton is the clockwise moment. That is similar to the anti-clockwise moment. Anti-clockwise moment is 1 into R1 plus 4 into R2. From where you get 4? From A to D would be 1 meters plus 3 meters, that is 4 meters. Therewith that you get the second equation as R1 plus 4R2 equals to 50. This is my first equation or equation A and equation B. Now you perform two simultaneous equations. By solving these two simultaneous equations, you can get the answers for R1 as 20 over 3 and R2 as 40 over 3. If you are still struggling how to solve simultaneous equation, watch the video the simultaneous equation. I'll put the link at the description box, as well as it will pop up as the suggestion video at the top of the screen. If you like this video, put a thumbs up and share this video with your friends. And to watch more educational videos, subscribe my channel and click on the bell icon. Hope to see you from next videos. Thank you.